that. Okay, so we'll talk about implicit differentiation today. I'll share my whiteboard. Okay. Can you see my whiteboard?
Yes, I'm able to see.
Okay, perfect. So let's talk about what simple differentiation is. Simple differentiation. Okay, it's a big word, right? So let's talk about simple differentiation and then we'll talk about the implicit differentiation, right? When we were talking about simple differentiation, the questions were of this type. We were asked to differentiate x squared with respect to x, or maybe we had x plus 1, or 2x plus x cube. In short, all the questions we had, in those questions, the function was in terms of x only, right? Do you agree?
Yes.
Okay. So this is what we have been doing. But let's talk about something different now. What if you have been asked to differentiate this type of a question, or maybe where you only have y, where function is in terms of x and y both, okay? In these cases, we are going to differentiate using implicit differentiation. So in the beginning, I just want you to know the difference. Just like some clues we prepared when we were talking about the parametric differentiation, when I told you that number of equations would be 2 and we would have 3 variables. So in this case, our clue is that the function which we would be differentiating would be in terms of x and y both. Okay, we would be having a y in case of these differentiations. This is the difference. This is how you would know that, okay, this is implicit differentiation and it is not simple differentiation. Do you understand the difference?
Yes.
Okay, so I'll ask you now, what if you have been asked to differentiate this, or maybe this, or maybe this? Okay, this is 1, this is 2, and this is 3. So which of these 3 cases is the simple differentiation case? Is it 1 or is it 3? Simple differentiation.
Simple differentiation, 1.
Simple differentiation. Simple differentiation. The function here is y squared. The function here is x squared. The function here is y plus x.
Yes, so the 1 and 2 are simple differentiation. 3 is implicit.
Okay, now look at this. In 1 we have y squared. So y square,
Yes.
y square is not simple differentiation. Simple differentiation is 2 only. Simple differentiation is just for those functions where we have x only. But for implicit differentiation, we have 1 and 3 because we have y here and we have x and y both here. Okay, this is for,
Oh, okay.
yeah, it's like that, and even for these cases as well, right? We have been practicing different questions which had exponential function, logarithmic function, fractions, product rule. We have used all that, but in all those questions, we were differentiating with respect to x. We are doing the same thing now, but the function in those questions used to be in terms of x only. But now we have y. Okay, this is a difference. You can check all your homeworks. Just have a look at your homeworks. All the questions in your homework were of this type. You were asked to differentiate with respect to x and the functions were of x only. This is what we have been doing in the homeworks, right? ex
Yes.
squared dx. There wasn't any y over here. We used to have y like this, and then you used to differentiate it this way. But this used to be the simple y, and this used to be the subject already. But in these cases, y is neither the subject nor it is the simple y. We are having y square here, and here we are having a mixed function. So if we are having a mixed function, it is implicit differentiation. And if it is just a function of x, it is simple differentiation. This is a very basic difference. Do you understand it now?
I do.
Are you sure?
Yes.
Okay, I will move to the next slide and then you would be able to understand even better. I'll stop sharing my screen and I will share my Microsoft whiteboard and I'll share my implicit differentiation slide. Mm, implicit differentiation, no, not this one. Um, implicit differentiation. Okay, that's the question. Yeah, here it is. Implicit summary. Okay. So this is, yeah. Is it readable? Just read the first five points. Okay. So this is what implicit differentiation says. Differentiate both sides of equation with respect to x. Okay. So this is the question in our case. And here, obviously, we can see that things are different. We have both
And Y.
x and y. Okay, we have x and we have y, and this is a simple case. We can make y the subject. We can by simply doing y cube minus, we have 5 minus 2x square y cube equals 5 minus 2x square divided by 3. We have minus here, and then we can use this. So in this example, we can make y the subject. This is not a difficult thing over here. But in questions where uh, you would be given 2 marks only and you have been asked to differentiate it, you would not be first making y the subject. And this type of differentiation is easy, but it is time taking. So this is not advisable. In these types of questions, you need to follow implicit differentiation. Whenever x and y are mixed, you need to follow implicit differentiation. You can always make y the subject and solve it. They would give you marks if you are able to do it easily and if your answer is correct. Okay. But if the question says to use implicit differentiation, or if the question is of the type that you would not be able to, if that you are not being able to separate y and x, in those cases you will be using implicit differentiation. Okay, right. So coming back to our topic, we have to differentiate this equation, and we can see that x and y are mixed. So we have our clue. We need to use implicit differentiation, but now the question is how to apply implicit differentiation. So step one is to differentiate both sides of the equation with respect to x. Okay. So we have, this is the left hand side, this is the right hand side. We need to differentiate both sides with respect to x, and this is what we are doing. When we'll differentiate 2x square, 2 would come as it is, and the derivative of x square is 2x, so this would be 4x. You understand this?
Yes, I do.
Now this is the important thing. Okay, 3y cube. When we are solving questions through implicit differentiation, we have 2 points that we have been discussing in our previous classes as well. Number one, you will be using the product rule. Number two, you will be using the chain rule. Here you will use the chain rule because you have 3y cube and you need to differentiate it with respect to x, and I have told you already, to do this you will use the chain rule. How? You'll be differentiating it with respect to y, because you cannot differentiate y cube with respect to x. You cannot say that the derivative of 3y cube is 0. Why? Because y is a function of x. This is what you know, right? It is a function of x and you are not being able to make it look like subject of x. This is why using implicit differentiation. So keeping it short, coming to the point, whenever you are applying implicit differentiation and you come across this point where you have to differentiate 3y cube or any function of y with respect to x, you will use the chain rule. We will practice questions after this, so you will get a better idea, okay? And this is how you apply the chain rule. You simply write down d, the function that you have to differentiate with respect to x, equals. Now we'll apply the chain rule. If we have a function y, we can differentiate it with respect to y into dy by dx. And now the trick I've been using, just so you can memorize it easily. If I cut it, although we cannot, but if I do, you would be left with this and this is what you had to differentiate. Okay? Is it clear? Is the trick clear?
Yes, it is.
Okay. So we'll be having a zero here because derivative of any constant is zero, right?
Yes.
Okay. So let me just move it. Okay. Now the second point says, apply the rules of differentiation if an expression involves y, then include dy by dx. Okay. We have already applied the rules of differentiation and this expression involved y. So we used the chain rule and we ended up getting a dy by dx. This is basically our ultimate goal. We need to have dy by dx in these questions because in the end we'll be making it the subject of our equation. And this is how we will get our dy by dx. Okay. So coming back to this point, we are done with the second one. We first step was to differentiate it with respect to x. We have used our previous knowledge and differentiated it with respect to x. This thing was a new thing, but now we know that whenever we have implicit differentiation, we'll be using the product rule and we'll be using the chain rule for sure. For sure. And this is how we're using the chain rule. You differentiated 3y cube with respect to x. You cannot write 0. You know that y is a function of x, but you can differentiate y cube with respect to y. So you had to use the chain rule and this is how you will be differentiating it. Okay. Okay. Now we are here. So once we are here, we need to take this 4x to the other side. Why? Because we need to make dy by dx the subject of our equation. This is what our goal was. We need to find dy by dx. So we have minus 9y squared dy by dx equals minus 4x. And we have dy by dx. We will take this 9y squared to that side. Okay. And just give me a second. Yeah. Now they are saying factor out dy by dx. This basically means to make the subject, right? And solve for dy uh, by dx by dividing. We finally take this 9y squared to that side and we have dy by dx the subject of our equation. And this is what our goal was. In this question, the equation was not of the type y equals 2x square minus 5. If we had it in this form, automatically when we'll be differentiating it with respect to x, this is what we would have on the left side of our equation. Okay. But in our example, we had 2x square minus 3y cube equals 5, and we were not able to get this directly. But we had to get this. We had to find this. This was the question. We had to find dy by dx. So this is how we do it in such type of cases. Okay?
Able to hear you.
Sorry? Hello?
Yes, now I can hear you.
Yeah, okay. So I was saying that if we had a question of this type and we differentiate it directly with respect to x, this is what we get for x, right? We get dy by
Yes.
dx here directly because our equation was in this form directly. The difference in our example and implicit differentiation is that the equation would not look like this one. The equation would have x and y mixed. When we have x and y mixed, we need to use implicit differentiation. And our goal was same. In this and in this, we had to find dy by dx. But luckily, when we had a question of this type, and when we differentiated with respect to x, we automatically get dy by dx on the left hand side. But in this case, things are different. We need to simplify things. We need to use the chain rule to get this dy by dx, and then we have to make it the subject of our equation. Is it clear?
Yes.
100%?
Yes, 100%.
Perfect. Okay, so let's uh, consider another example. Wait, I will use whiteboard because now I'll be solving the question. Let me know once you're able to see my whiteboard, okay? Can you see my whiteboard?
Yes, I can.
Okay. So let's solve an example. Okay. Okay, so the question says find the gradient of curve with equation 3y square minus 2x cube equals 10 at 1 2. So this 1 2 is the point and this is the equation of our curve, and we have to find the gradient. Okay, this is the question. Now, whenever we have gradient, we know we need to find dy by dx. Okay, this is what we know. Right, this is what we know.
Yes.
And our equation is not of the form y equals f of x. Y is not the subject of this equation. So this is our clue, and this is how we would know that okay, we need to find dy by dx of an equation where we do not have y as the subject of this equation, right?
Yes.
So I will undo this to keep things neat, and we know that we will use, what are we going to use?
Uh, dy by dx, we have to differentiate both sides with respect to x.
Very good, but we will be using
Yeah,
implicit
implicit
differentiation.
differentiation.
Okay.
Yeah.
Yes, very good. So we will be using implicit differentiation. So step one, differentiate both sides of the equation. So I will do things stepwise just so we are clear with every step. Equals d dx and 10. Right. Now we need to differentiate this function and this function. So Ranjini, what would be the derivative of this 3y square?
3y square will be
Take your time. Take your time. Now we have to
will
differentiate
it
this.
be 6y?
Wait. Okay. Wait. Let's see. Okay. What are you saying? What is the derivative?
6y.
But is it being differentiated with respect to y?
No, with x.
So how can
So
you
you have
say
to use the
6y?
chain rule.
Very good. Okay. Be very clear with this. Be very clear with this. You have x over here. So when you have x over here, you cannot consider um, this as the variable. This isn't x. This is y. If this was x, yes, in that case, our derivative would be 6y. But here it is x. So we will use the chain
Chain
rule.
rule.
And what is the chain rule? How am I going to break it down and to do it by chain rule?
dy by dx equals
No, this is not dy by
uh,
dx. This is d3y square by dx. Yes. Take your time. You can do it. You can do it. Don't worry. Hint is that our third variable or third thing would be y. Okay, listen to me. Listen to me. I am asking you to apply the chain rule. No problem. Okay. The trick for chain rule is you need to differentiate this fraction, right? So it would be something of this sort. And here and here the things would be same because as per my trick I told you we'll be cancelling out these two just so we are left with these two. Remember?
dy.
Excellent. And y dy, just remember it as a rule because your derivative would be 6y only if you have dy here.
Yes.
So the derivative would be, now tell me the answer. What would be derivative in this case?
D by dx of 6y.
6y and
6y and d by
6
dx.
dy dx. Very good. Okay. So this is what we are going to have over here. I will use the eraser and then I would not be able to write ever again. This is what happened last time. No, sorry. Okay. So this is, please help me. What am I going to write over here?
6y dy by dx.
Excellent. And now over here, minus, what
Minus
would be
6x squared.
excellent? So now
Minus
we
6.
have 6x over here because this is x and this is x, but never ever do this. Okay, never ever say that the derivative of 3y squared with respect to x is 6y. No, please, no. Okay, the variables are different. We cannot do it this way. We need to use the chain rule. Okay, and what is the derivative of 10?
Nothing, 0.
Very good. So what is the next step?
The next step is you have to bring negative 6x to the other side. So
Very good.
6x.
And now
Now you have to bring 6y to the other side as well. So 6x squared by 6y.
and why am I doing this? Why am I separating everything from dy by dx?
Because you need to find dy by dx.
Excellent. So you are clear with everything. The only thing you get confused with is this chain rule, but you'll get better with that as well. Okay, excellent. So we have x square y. And what was the question? The question was to find the gradient at this point. So what is our next step?
You have to substitute 1 and 2 in that.
Very good.
So
So my answer is 1 by 2, right? Is it
1
clear?
by 2. Yes.
Okay, perfect. Now I'll do another example and I want you to help me completely, okay? Just like you helped me with this one. Let me write down the question. This is the question. Okay. So the curve C has equation x cubed plus 9x y squared equals 54. Part A says find the gradient of tangent to C at the point 3, 1. This is the first part and then we'll discuss the second part later. Okay. So what are we going to find? The gradient.
Yes.
And what is the gradient? Dy by dx. And what is the type of equation?
Implicit.
Is
Because
it
there's X and Y both.
excellent? So we step 1 is to
Differentiate both of them with
ve-
respect to X.
very well done. So let me just write down that. Okay, this is clear. Now how am I going to differentiate this whole thing?
Okay, the first one will be 3x squared. So
Excellent. And let's do the
the
second one
next
slowly,
one,
okay? Okay. Now this is the second function. And how
this
am
has
I
X
going?
and Y both.
Sorry?
This has X and Y both. So you have to use the product rule.
Excellent, excellent. Very well done. We'll be using the product rule. And how am I going to execute it? Let's take
By
9x the
using the
first function, okay? So, or do it
nine,
whatever way you were telling me to. Just say it.
uh, 9. So we have to use
Mm-hmm.
the product rule. So
Mm-hmm. Take your time. Take your time. It's completely okay. You can take time. No problem at all. So this is first function and 9x is the second function, okay? And let's say
F of
that,
X will
yeah,
be
let's say
9.
9x is
9.
the first function. So what is the product rule? Take first function as it is and differentiate the second one. So for now, I'll just write down like this. I would not be differentiating in this step, okay? Because things would get very complicated. This is what I've written. This is what the statement says. First term would come as it is and derivative of the second one. So this is what the derivative of second one would look like. Oh, we will expand it later on, okay? Plus second function
Uh,
would come as it
9.
is. Yes, very good.
Yeah.
And this is the derivative of first one. Excellent. And what is
Yes.
going to come here?
0.
Very good. I don't like this brown color. Let's use the blue one. Okay. So 3x square plus. Okay, tell me how am I going to expand this now?
So you
Let's,
have to use the
yeah,
chain rule.
very good.
So
So what about this 9x? I should write it down directly?
yeah, directly.
Very good. And now, what about the, now how am I going to solve it or break it down? You are right. We'll be using the chain rule, but yes, what is the next step? Okay. Now this is what you need to differentiate, okay? And you know that you will use the chain rule, but how? Okay. So this is the numerator, write it down. This is the denominator, write it down. You need something over here and here which is going to be same, and something with which you can differentiate this y square. What could that something be?
dy.
Very good. And remember this, you will always be using dy, okay?
Okay.
Just remember it as a rule. You will be using dy. Obviously, if the variable is t in this case, I mean, then you will be using dt. But whatever the variable is in numerator, don't worry, it would be y. But don't memorize it, okay? Just be clear with the concepts. You need to differentiate this. You cannot do it directly. You need to apply the chain rule, and this is what the chain rule is. You have dy square, you have dx. This is the trick. Write down two fractions with a product sign. The numerator would have this numerator, denominator would have this denominator, and these two things would be same, and it would be something with which you can differentiate this dy square. So that would be dy, obviously, right?
Yes.
This is 0, and now we have 3x square plus 9x, and what is going to come here? What is
9x plus dy square by dx.
no? Sorry.
9x
Now you need to
dy
differentiate this. You need to differentiate this.
2y
Very good. dy.
2y by dx.
No, this would be 2y, right? The answer of this would be 2y, just like the answer of dx square over dx would be 2x, right?
Okay, yeah, I got it.
So this would be 2y, and this is a totally separate thing. And remember, never ever mess up with this dy by dx, because this is what you have to find. Okay?
Okay.
Now, what are you going to do next?
Next, you're supposed to take
Mm-hmm.
3x squared to the other side.
Very good, as well as this 9y square as well. And I'll
Yes.
divide this 9x
Divided by,
and
yeah,
2y
9 is
directly.
2.
Okay. Now I'll put this 3 and 1, and my answer would be minus 2 by 3.
Minus
Okay.
2, yeah.
Yeah. So this is what we know. This is an easy part, but this is the part you are uh, getting confused at.
Got it now. One more question. I will do it right
No,
this
no,
time.
it's totally okay. These are things that you are viewing and looking for the first time. You need to practice only, okay? I'm recording these lectures for you. I understand that obviously you are going through a really hectic routine. You are applying for universities as well. I totally understand that. But remember that you have your mocks as well, okay? So after these classes, just take out 40 to 50 minutes. You can watch these recordings. I think you can double up the speed as well, in case I used to do that. But you can always do that, and then you can take 30 minutes and practice 3 to 4 questions, because every day we are covering just one topic. So if we are covering one topic, 3 to 4 questions from that topic are good enough, okay, for practice, right? So okay, so this was the first part. Now let's talk about the second part. We'll be having a quiz on Friday, and I want you to get at least 85%, okay? Because then your mom will be knowing if I'm teaching you well or not. So you need to practice a lot. The test would be easy, but still, okay? Watch these recordings again. Ask me 100 times. I would not mind it. You can call me directly. I would not mind that, unless I'm in front of my boss. So yeah, in that case, I would not be able to answer you. Okay. So the second part was, yes, oh, I did not write the second part. Okay. Yes, okay, doing the same thing. Yep. Oh God, why is it? Yeah, okay. Second part. Let me just take out the question quickly. The second part says, hence, find the equation of normal to C at 3, 1. This is the second part. So our dy by dx at 3, 1 was minus 2 by 3.
Yes.
And what is normal?
Normal is a line that's perpendicular to the
Excellent. Very
tangent.
good. Yeah. And what is the concept? Do you know the underlying concept about the derivative? What would be the derivative of this normal? If this is the derivative of tangent, the derivative of normal would be, okay, I'll tell you. Derivative of tangent into derivative of normal is -1. This is the rule, okay? So derivative of tangent is
It's just the
minus,
same as straight line, like straight line graphs.
yeah, that is right. But
Perpendicular line. Okay.
okay, but what is the derivative of normal? I'll tell you.
Derivative of normal.
I'll tell you. Derivative of normal 3 by 2. Okay. This is not part of this it's not part of implicit differentiation. It's a past paper question. I mean it's a question from your book, but it is similar to a past paper question. So basically, in the previous part, we calculated the derivative of this curve of a tangent to this curve at the point 3, 1, right? So for now, just know that this dy by dx was minus 2 by 3, and this minus 2 by 3 was the derivative of this tangent, okay? And the concept is, if this is the tangent, let's say, and this is the normal, these are two perpendicular lines. So derivative of tangent into derivative of normal is -1. This is a formula, okay? It's this formula exists. We should know this formula.
Okay.
So if the derivative of tangent is minus 2 by 3, and we need to find the derivative of normal, that would be x, okay? And if I make x the subject, we have -1 here. I'll take this 3 and 2 there, so I would get 3 by 2. So this is the derivative of our normal line, right?
Yes.
Very good. So now it is a straight line. We have different equations for straight line if we use this slope intercept form, right? So y naught is 1, y minus 1 equals, what is m? 3 by 2. This is x minus 3. So the equation would be 3 by 2x minus 9 by 2 plus 1. So this would be, this is minus 4.5. This would be 3.5. So it would be 3 by 2x minus 7 by 2. Y equals this. Okay. This is the equation. I'll explain you. This hence basically is telling us that we need to use the previous part. The previous part had the derivative of this tangent. Okay. And is this formula new for you? Are you not familiar with
No,
this
no, I'm
formula?
familiar with this formula.
Sorry?
Yeah, I'm familiar with this formula. I know.
Okay, so do
I
you
can understand.
understand this question?
Yes. Once you found the
Derivative?
yeah derivative, so that'll be the equivalent to the
M.
gradient. Yeah.
Yep, very
So
good. Yes.
and then you just substitute the x and y values.
Excellent. Yeah. Okay, this is how I did this. It's clear now.
Yes.
Sure. So should we move to
Yes.
our integration chapter?
Yes, we can.
100% sure?
Yes, 100%.
Obviously, if you get across some questions that you're not being able to understand, you can always ask me. Okay, there's no hard and fast rule that if we are discussing integration chapter, so you cannot discuss. It's not like that. Okay, so let's discuss our first topic, that is trapezium rule. Now, this is the topic, and at the moment we don't know anything. We'll start our discussion and then you'll get a better idea. Okay, so I have this graph, and this is our curve. Okay, this is y, this is x, and y is basically under root x minus y in this case. Okay, y is any function of x. This is a curve. This is 1, this is 2, 3, 4, 5, and 6. And we have some values of y over here as well. Okay, right. Now, if I ask you to find the area under this curve, how would you attempt that? If I ask you to find the area under the curve.
Area under the curve, I have to integrate it from
Very
1
well done.
to 1 to 6.
Excellent. Okay. So you are saying that one method to do is to integrate it from x equals 1 to x equals 6. Okay, perfect. Excellent. This is one method of doing it. Okay. And in this case, our function is really easy. So you can integrate it directly. But if the function is of the form that you are not able to integrate, okay, or the question asks you for an approximation, and the question asks you to use the trapezium rule and approximate the area under the curve. So this is what we are going to discuss now. Okay, we are clear with this, that yes, we can integrate this curve from x equals 1 to x equals 6 to find out the area under this curve. But if the question says to approximate, or if the question asks you, or if the examiner asks you to use the trapezium rule directly, so we'll be using the trapezium rule to find the area under this curve. Now let's discuss the trapezium rule. Okay, we can discuss it. But for discussing the trapezium rule, we need to draw some trapeziums. Um, give me a second. I'm trying to draw trapeziums. Okay, all these yellow figures are trapeziums. I'm not being able to draw them properly because of my pen. But these are trapeziums. So if any line looks like a curved line, just ignore that. It is a trapezium. Okay. So I have 1, 2, 3, 4, 5 trapeziums. Right. So these are trapeziums, and this is what a trapezium looks like actually. We have a straight line, we have two lines that are parallel to each other, and then there's a line which is connecting these two parallel lines, but it is a slanting line. Okay, this is how a trapezium looks like. So now we are trying to approximate the area under this curve. Okay, and I am saying that we have to use the trapezium rule. So the trapezium rule says calculate or find the area of all these trapeziums, and this area, sum of all these trapeziums, would be the area under this curve. Now again, it is not going to cover up all the area. We have these spaces which are not coming under these trapeziums, but then this is what I meant by approximation. Okay, the trapezium rule is always going to give you an approximation, and the rule basically is to find out the area of these trapeziums, sum these areas, and say that this is an approximation to this area under the curve. Right, do you guess, do you get the initial idea of what trapezium rule is?
Yes.
Okay, so I will directly go to my Microsoft whiteboard and I'll share an image and I'll discuss it over there now. Hmm, trapezium rule. Okay. Can you see my screen?
Yes, I can.
Okay. First, we are going to read it in detail and then we will discuss. Right. So, the trapezium rule. We already know that area A under the curve y equals f of x between x equals a and x equals b. This is the area A. This is the curve. This is the curve y, and this is a point and this is b point. So we already know that area under this curve can be found by evaluating this integral. We already know that. But sometimes we might not be able to find the value of this function by integration methods that we have covered so far. So maybe function will be integrated algebraic. Okay. So the rule says that basically it could be that you can find the area under the curve using the integration. But if this f of x is of such a form that you have not discovered so far, you have not discovered its integration so far, but still you have to find an approximate answer. In these situations, we approximate answers by using this trapezium rule. Okay, all
Yes.
right, right. So let's say this is a curve and you need to approximate the area. To approximate the area, you will not plot these trapeziums every time. We have this formula, we will use this formula directly. But just to clear up your concept, you should know that the formula that we'll be using, I'll show you the formula now. The formula, this is our formula. Okay, this is the final formula. We use a better color. Okay, this is the formula which we would be using directly. The underlying concept behind this formula is this diagram. This is a curve. You have been asked to find the area under the curve from x equals a to x equals b. You will be making these trapeziums. Although these trapeziums would not be covering every single area, but you would be able to find an approximation. So the area of a trapezium is 1 by 2 sum of parallel sides into width. This is what the width is. in this case. Okay, if I talk about this trapezium particularly, this is its width, and y0 and y1 are two parallel sides. But this is the case of this one trapezium only. If I talk about all of these, we have this formula. For height, for width, remember, this h is the width, okay? This h is the width. We have 1 by 2, we have 1 by 2, width, sum of parallel sides. So this is the first triangle, we have y0 plus y1. So this is basically the area of this triangle. Now we have this one, 1 by 2 width into sum of parallel sides. So 1 by 2 width into y1 by 2. Okay, this is the sum of parallel sides. So we're talking about this now. We are done with this. We are done with this. If we talk about the third one, we have y2 and y3 as parallel sides. So this is our third, fourth, fifth, and so on. One thing you will see that in this formula, we have y0 once only, and we have y6 once only. But we have y1 two times, we have y2 two times, we have y3 two times, we have y4 two times, and we have y5 two times. And why is it coming two times? Because this side, every side other than the outer boundaries is basically being used twice. It is being shared by two trapeziums. So final formula would look like this one. Y0 and y6 would come once only. But this y1 is coming twice, this y2 is coming twice, this y3 is coming twice, and so on. So we have a 2 over here. And then we have y1 plus y2 plus y3 and so on. Okay, it's just a simple simplification. That's it. Okay.
Okay.
So it is one of the most easiest concepts, trust me. The only thing you need to know is that, okay, if you have been asked to find out the area, I'll move on to the question and I'll show you. Okay, this is the underlying concept. It's just like the proof. It's just like the proof of the product rule, where you said that, ma'am, are we supposed to do the proofs as well? So this is just the proof. Let's talk about the example, and then you'll know what content you need to remember, and you should know the underlying concept as well. Okay, I'll share you I'll share. Let's talk about this question. Things would be very clear after this. Okay, now here we have the diagram shows the curve. Use the trapezium rule with four intervals to estimate the value of this, giving your answer correct to two decimal places. Okay, now you need to estimate the value of this. Okay, either you would be estimating the value of this integral or area under the curve. So think the same, okay? Area under the curve is basically the integral of this curve. So the question would be, you need to estimate the value of this. Okay. Now you need to estimate the value. You'll be using the trapezium rule. Fair enough. And you are not supposed to plot any trapezium to do something of that sort. No. All you know is that this is 0 and this is 4, and you have four intervals. So you will be making four intervals. We have 1, 2, 3. So we have, this is our first interval, second, third, and fourth. Okay, this is the first one, second one, third one, and fourth one. So this would be, and when they're saying intervals, the intervals are equal intervals. So if this is 4, this would be 1, this would be 2, this would be 3, and this would be 4. Okay, so we know our x's 0, 1, 2, 3, 4. Now we need to make our trapeziums, and look, in this case we have triangles, but it is completely fine. You will still be using the trapezium rule, and in this y0 you will insert 0. So automatically your formula would be of the triangle. Okay, we are clear with the x's. Step 1 was to know what your x's would be. And how are you going to determine your x's? You have your interval, you have 4 intervals, and it is from 0 to 4. So simply 0, 1, 2, 3, 4 would be the axis. Okay,
Okay.
and this is how your trapezium would look like. This is the triangle, but it is completely okay. It is a triangle, it is a trapezium with one parallel side equals to whatever this is, and this is basically f of 1. Okay, and this is 0. Okay, from exam point of view, now I'll tell you from exam point of view. You have been asked to estimate the value of this integral. How would you do that? You'll be using the trapezium rule. Why? Because you have been asked to estimate, and then they have this trapezium rule as well. Okay, so it is clearly mentioned. And step number 2 is to know your x's. The final x is 4, the initial one is 0. So a is 0, this is x1, and b is 4, this is the final x, and b minus a divided by n, that is 4 minus 0 divided by 4 is 1. Now what is this 4? This 4 is the number of intervals. And what is this one? This one is the height. This one is the width. Sorry, this one is the width, but we use h. This is the width. Okay, I say height every time. I'm sorry, but it is the width. And this width would remain same in case of every trapezium. So for your exam, you just need to know this formula. You know your h would come like this: b minus a divided by n. 4 minus 0 divided by 4. 4 is the number of intervals. This is the final x limit. This is the initial x limit, and this is 1. And you have h. Now, what is y0, y4, y1, y2? Okay. You have 0, you have 1, you have 2, you have 3, you have 4. This is what we calculated initially. You simply need to insert these values into this function, and you'll get your y's. Okay?
Okay.
It's okay. We will discuss this in our Saturday's class. It's completely okay. So I'll stop the recording, and you can ask me whatever you want. So I'll stop the recording.